Hello everyone. In this video, we are going to discuss about routing information protocol, that is a RIP protocol. So this protocol is working based on the distance vector algorithm. So that is a thing we discussed in your last video using the Bellman-Ford equation. So it is finding the minimum cost for the each and every node that is going to be updated with the forwarding table. Each and every neighbors are forwarding its own distance vector to the others. So based on that, the values are going to be keep on updated with the help of Bellman-Ford equations. So now the basic principle of the RIP protocol. RIP protocol, it's interior gateway protocol. So the interior gateway protocol in the sense, so we know very well it will be working the inside our autonomous systems. It is a very simple protocol based on the distance vector. If the autonomous systems, it contain the routes and links, so that is going to be describing our nodes. So in this routing table, so we are just telling about the routing table or forwarding table. So the routing table, it contains the three columns. The first column, it is giving the information about your destination network address, and then second column, it is going to be described about the next node, what is the immediate next node for the um, source, and then the third column is the metric, that is the cost. Okay, so address of our destination, it will be describing here, and then address of the uh, router, that is a next node router, and then metric is nothing but our hop count or cost. Okay, so the RIP used very simple. The distance is defined as the number of links here, that is a links is nothing but our network. So how many networks we need to travel. For example, this is our network structure. So network 1, and then network 2, and here network 3, like this means. So in between the network 1 and 2, the router 1 will be connected, and it will be network 2 and 3, router 2 connected, and then again one more network, we are just having network 4 means router 3, so like this. Okay, so that now we need to reach the network 4. So this is our source network, and this is our destination network means. So how much networks we need to crosses. Okay, so our immediate network is router 1. So router 1 2, we need to jump to the next. Okay, so hop counts we are just going to be calculated here. So jumping from the uh, one to another to reach our destination. Okay, so to reach the destination network, so here 1, so router 3 to 1, and then router 2. So from here means 2 networks we need to cross it, and here to here. Okay, so router 3 to here, the hop count is 1 hop count. Router 2 to here means 2 hop counts, and router 1 to here means 3 hop counts. So 1 2 and 3. Okay, so from here 1 and 2. So from here this is 1. Okay, so this is nothing but our hop count. So this hop count is going to be entered here as a matrix in this third column. Okay, for example, the same example, the forwarding table for the router 1. So for the router 1, the three columns, right? The first one is destination address, and second one next router, and third one is cost or metrics. Okay, for the router one we are just calculating. So what is the network? We just make the same and just make it here. Network 1, the same diagram. Okay, so now the destination address for all the networks. So network 1, network 2, network 3, and network 4. So the next router, so the network 1, any next router is there now? No, because that is directly connected to your R1. So there is no intermediate routers. Okay, so there is no next hop. The cost to jumping to the network 1 is 1. The cost is 1. Similarly for the network 2, there is no next router. The cost is 1. Okay, from the router 1 to router 3, now we need to reach, means through the router 2 only we can able to achieve it. So the next router is R2. So what is the hop count? 1 and 2. So hop count is 2. And network 4. So to reach from the net R1 to R4, again through the router 2 only we can able to reach it, not router 3. The next router to the R1. So which one is the immediate router for the R1? So the next router is R2. The cast 3. Okay. So from here again the forwarding table for R2. So what is the forwarding table for the R2? Again the three information we have to mention. So all the destination address, next router, and then cast. Network 1, network 2, network 3, network 4. So what is a network 1? For the R2 we can't able to reach it directly, so through R1 only we can able to reach it. So R1 is the next router, cast is 2. So reverse, jumping here and there. So for the network 2 it is directly connected, so there is no next hop router, count is 1. For the network 3 is also directly connected, cast is 1. Network 4, again it's not directly connected, through R3 only we can able to reach the R4. For the R2 to reaching the network 4, the immediate router is here. Okay, the intermediate router. So for reaching the R4, intermediate router is R3, the hop count is 2. So then the routing table for R3, forwarding table R3. Sorry. Again the destination address, next router, cast. Network 1, network 2, network 3, and network 4. Network 1 again next router. From the R3 the next router is R2. The cast is 3. Network 2 again through R2 only, cast is 2. Network 3 directly connected, cast 1. Network 4 directly connected, cast 1. Okay, so like this the forwarding tables are going to be created. So the R1 is defining the next router path for the network 4 is R2. From the R2 is defining the next router for the path for the network 4 is R3. So for the R3 is there is no next router. So Now the path is going to be identified to reach the network 1, router 1 and router 2 and router 3, then your network 4. So like that, the tree is going to be identified. Okay, so the forwarding the packets, but it not need for updating the changes of the routes. This is the uh, implementation of our RIP. So the RIP protocol is processing the services of the UDP, that is your user datagram protocols, using the well-known port of the 520. So this routing protocol to help the IP routes its datagrams through the our autonomous systems. The RIP messages are encapsulated inside the user datagrams. So the RIP is mainly runs in an application layer, but it's creating the forwarding table for the IPs at the networking layers. So the mainly the RIP having the two versions is there. So versions of RIP. So RIP v1 and RIP v2. So two versions are there. So RIP version 1, that is a message is sent. If it is the RIP version 1 means that it is going to be setting the 0 into the v1. So RIP version 2, it allows a more information about the RIP messages. Here the most important thing, the RIP having the maximum cost of the path, that it will be the 15 hop counts. Okay, so the hop count we just counted in your previous thing, right, from the network 1 and router 1. So jumping here and there, so this is the hop counts, right? So the maximum hop count is the 15 for the RIP. So that is the main disadvantages of the RIP thing. So the maximum, the limit, the autonomous system is the 15. Based on that, your structure is going to be a large, so this protocol will be helpless for us, so we can't able to reach if it is gone for the 16 hop counts. So each and every it is a sending messages, RIP messages, we are just having the two processor, client process and then server process. So the message formats, it will be the, so messages are which will be calling the entry, or it can be repeated, it's needed in a messages, a response messages or sending the messages. So each entries carries some information related to the one line in the forwarding table of the source, and it sends the messages. So message format for the RIP looking like this. So this is the message format of your RIP. So the first thing, it will be called as the headers. So this is a 32-bit 0, 8 and 16 and 31, like that it will be divided. So the three thing will be there. So first one is the uh, command, and second one is going to be indicated about the version, and remaining thing, this is for the reserved purpose. Okay, and then this is the part is family and tag, and then third part is for the network address and corresponding subnet mask, and how many hops, that is a next hop address, and then final distance. Okay, so the first thing is command. So either it is the request command or otherwise it's a response command. So that is going to be indicated here. So if it is a request, the value it will become as a 1, and if it is a response, that value is going to be become as 2. Okay, then similarly the version 1 or 2, that is going to be indicated here. The request means 1 and response means 2. Okay, and then family, so it belongs to what kind of the family, the TCP/IP, so like that. And then tag is information about our autonomous system, the informations are giving here. And network address, so we know very well our destination address going to be displayed, and corresponding the subnet marks, so based on the prefix length. And then next hop address length is mentioned, and then distance, obviously we know very well the number of hop counts. Okay, so these are the informations are specified this. So this is a general message format of our RIP protocol.